आगे 95 to 8.
Good evening, students.
Good evening, sir.
Good evening, beta. Good evening, beta. So in the last class, I was discussing moment of inertia. Moment of inertia. So I have discussed various cases of moment of inertia related to the disk. Now suppose you are having a uniform road. Next is uniform road. Suppose length of the road is L and mass of the road is M. So here we are having a uniform road. Uniform road means mass per unit length. Okay, linear mass density that is constant. So this is a uniform road. So uniform road means lambda. Okay, mass upon length. Okay, this is constant. So this is mass per unit length. Mass per unit length. or you can call it as linear mass density. Linear mass density. This is constant. What is this? This is constant. So mass distribution is uniform throughout the road. Length is L. So now I want to rotate this about this axis that is passing through its center. So I'm starting with a simple problem. This is the center of the road, and an axis, Z axis, suppose it is passing through the center C of this road, and it is rotating, road is rotating about this. Then what will be the moment of inertia? What will be the moment of inertia if you about this axis that is passing through its center and perpendicular to its length? So how you are going to do? You can consider that this road is made up of two parts. One, I consider it as origin, and on this side you are having positive, so this will be plus L by 2. On this side I can consider it as minus L by 2. Okay? So you can consider this road is made up of two parts. One, this 0 to L by 2, and this 0 to 0 to minus L by 2, and they are rotating like this. So whatever will be the moment of inertia due to this, okay na? Whatever will be the moment of inertia of this part when it is rotating about Z axis, same moment of inertia will be for this when it is rotating. So they are going to have same moment of inertia about the Z axis. About the Z axis, I have drawn in the diagram. It is like this. So for this purpose, what you are going to do, consider a length element here. Its length is dx, and this length element, this is at a distance x from the axis. So what we have done, we have considered a infinitesimal length element dx at a distance x from this axis of rotation. So what will be the moment of inertia of this element? This will be lambda into dx. This will be the mass of this length element. Okay, mass per unit length is lambda. So what will be the mass of this length element dx? That will be dm, you can say. This will be lambda mass per unit length multiplied by its length. So this will be lambda into dx. So this is dm. What is the distance from the axis? That is x square. X square. So if you integrate this, if I integrate this from 0 to L by 2, 0 to L by 2, then this will provide me the moment of inertia of this part, okay, when it is rotating about the Z axis. Same moment of inertia will be for the second half, okay, for this half from 0 to minus L by 2. So I'm multiplying it by 2. So this will be the total moment of inertia of this uniform road about this axis, about Z axis. If you are rotating this uniform road about this axis, then this will be the moment of inertia. Okay? So this is dm x square. I integrated it from 0 to L by 2. So this will be the moment of inertia of this half part. Same moment of inertia will be due to this, due to the symmetry. Okay? Because why this and this, they are going to have the same moment of inertia. If you forget this and this is rotating, what type of symmetrical structure it is going to create? Two-dimensional structure, disk will be created. Similarly, if you are rotating this about this axis, then symmetrical, similar type of disk will be created due to the rotation of this. So that's why their moment of inertia about this Z axis, that will be same. So that's why I have written here 2. So this will give me the total moment of inertia, okay, due to this road, due to uniform road about this axis, Z axis, that is passing through its center and perpendicular to its length. Now, what is lambda? Lambda is m by L. This is a constant, so I can take it out. This will be m by L here. M by L here. Okay. And what it will be? This will be 0 to L by 2. And this will be x square and dx. dx. This will be equal to, so I will be equal to 2 times m upon L. And this will be x cube by 3. So I'm writing 1 by 3 here, and x cube, this will be L by 2 cube. L by 2 cube. So this will be 1, 2 will cancel out from here, and 4, 3 are 12. So this will be ml square by 12. So moment of inertia of this rod, okay, about an axis passing through its center and perpendicular to its length, this will be ml square by 12. So you have to remember this formula. I have already used this formula, but this is the way you are going to calculate it. This is the way you are going to calculate it. Now, next is you can write it as IC. You can say this is IC. I have already done this. If you want to find out the moment of inertia about this axis, you are rotating about this, you can call it as I1. This distance will be L by 2. Perpendicular distance between these two parallel axes is L by 2. So by applying parallel axis theorem, you can find out I1. So what will be I1? I1 will be IC plus mass of this rod, x square. X is L by 2 here. Perpendicular separation between these two is L by 2. Substitute here ml square by 12 plus ml square by 4. So this will give you I1. I1 will be ml square by 3. So this will be ml square by 3. You have to remember both these formulas. Okay? So this will be ml square by 3. So about this axis, this will be ml square by 12. And moment of inertia about this axis, this will be ml square by 3. This will be. So this is for uniform rod. Please note it down quickly. Please note it quickly. Now, suppose this is the axis of rotation. This is axis of rotation. Okay? And I'm having this rod of length L. Suppose I'm having a rod of length L. ये इसका length कितना है बेटा? L है. ठीक है? And we are rotating this rod about this axis, Z axis, you can say. ठीक है? Then what will be the moment of inertia? That is I. I will be, you can say, suppose mass of this rod is M1, I am saying. So this will be M1, or I write 1 by 12 here. Sorry, 1 by 3. 1 by 3. This will be M1. And this will be L square. Whatever length is this. Capital L. M1 L square. 1 by 3 M1 L square. Now, I placed another rod here. Okay, I attached one more rod with this earlier one. Length is also L. Mass is M2. Its mass is M2. Now, this combined system made up of two rods, it's rotating about this axis. So what will be the moment of inertia? That will be 1 by 3 M2 L square. Even you can choose rod of same mass, identical rod also. If you want, you can choose identical rod. You can have another rod, uniform rods I am considering. This one. This will be M3, suppose. Its mass is M3. So what I will do here, I will write plus 1 by 3 M3 L square. Now this is the moment of inertia of these three rods attached together, and they are rotating about this axis. So this will be, and I continue to do this. I continue to add rods, different rods. Now this type of structure I am going to form. So you form this type of structure. Okay. So what will happen? What will the total moment of inertia? That will be 1 by 3. This M1 plus M2 plus M3 and it will go on and L square. L square. So what it will be, this I will be, this will be 1 by 3. This m1 plus m2 plus m3, this will be the mass of this rectangular plate. Now what you have done, by adding these rods together, you have created a rectangular plate. Okay? This is a rectangular plate whose length is L. So if you are rotating this rectangular plate about this axis, Z axis, suppose its moment of inertia, that is I1, I say. Okay, that is I1. And suppose total mass is m, so this will be 1 by 3 ml square. This will be. Okay, na? This will be better. So this will be the moment of inertia about this axis. Is it clear? Okay?
Yes, sir.
Good, beta. So it is like this. Now suppose next what you are doing. Okay, so you are having a plate now. So what you are having a plate. Now I remove this. I remove this. So this is a rectangular plate of length L. And this is the moment of inertia. Okay? Now what I do, I consider another axis. I consider this axis, beta. Now I consider this axis and I'm rotating about this axis. Okay? About this axis. Now I am rotating this rectangular plate about this axis. So you are going to get a symmetrical structure. क्या बनेगा बेटा आपका solid cylinder. You are going to get a solid cylinder, 3-dimensional structure you are going to get. So you can find out. Okay? Suppose its breadth is B. This is B. So I can consider again that this is made up of various or many rods whose length is B. So here you can consider like this, that this rectangular plate, it is made up of many rods, okay, whose length is B. Masses, they are M1, M2, like this. You can continue like this. So what will be the moment of inertia about this? I'm saying this is I2. So this was I1. This was I1. So what will be I2? I2 will be again, this will be 1 by 3. This will be M1 plus M2 and so on. And this time it will be B square because length of each rod here now it will be B corresponding to the breadth of this rectangular plate. So this will be 1 by 3 M B square. So this will be I2. I2. So basically here this is one axis which is lying in its plane. This is another axis, okay, which is also lying in its plane. So these two axes is this axis and this axis. Okay, you can consider it as x-axis. Okay, so that I can apply the right hand system. I remove it and I say, suppose this is y. I consider it as y. So this is x, this is y. So where will be z? Z axis will be here. Z axis will be like this. This is right hand system. This is x cross y and this will be z. So this will be the z axis. Now, what will be the moment of inertia if you are rotating this disk, sorry, this rectangular plate about the z-axis? Here you are going to have z-axis, z-cap axis, z-cap axis. If you are rotating this rectangular plate about this z, what it will be, what you are going to get? Basically, you can find out this one by using the perpendicular axis theorem. So these two axes, they are mutually perpendicular to each other. They are lying in the plane of the rectangular plate. So third axis is this one, which is passing through the intersecting point, and this axis is perpendicular to the plane of this rectangular plate. So what it will be? This will be I3. I say that this is I3. So what will be I3? I3 kitna hoga? That will be I1 plus I2. So I1 plus I2, this will be 1 by 3. This will be M L square plus B square. L square plus B square. This will be. This will be. Now, this is okay. So you have find out the moment of inertia about this. About this. Now you want to find out the moment of inertia about an axis that is passing through its center. This is the center. So this will be the axis perpendicular to its plane. Okay? And you are rotating about this like this. So now you know the moment of inertia about this axis. Now you want to find out the moment of inertia about an axis that is passing through the center of mass. This is center of mass. What is this? This is the center of mass of this rectangular plate. So that will be IC. How much it will be? You want to find out IC. So what will be my formula? That will be I3. I3 will be equal to kitna? IC plus mass of this rectangular plate into this distance. ये वाला जो distance होगा, I'm drawing this distance. ये कितना होगा बेटा? This is L square B square. So this will be the diameter. This will be square root of L square plus B square. तो ये वाला कितना होगा? This will be square root of L square plus B square divided by 2. This will be. So what is the perpendicular separation between these two parallel axes? This will be the square of this. So this will be L square plus B square upon this will be 4 here. So you can consider it as small l because we are choosing. So whatever small or capital you are choosing, you're going to consider the same here. So this will be here, this is L square plus B square, and I'm writing L square plus B square. So you want to find out this IC. So what will be IC? IC will be IC. This IC will be equal to I3. I3 is how much? I3 is this 1 by 3 m L square plus B square minus 1 by 3. This will be m will be there, L square plus B square, and m is here. You write m here. Okay, this will be 4 beta. This will be 1 by 4. This will be 1 by 4. Now take the LCM. So 4 minus 3 is 1. This will be 1 by 12. What you are going to get? This will be 1 by 12 m L square plus B square. So this will be IC. So this is the moment of inertia of this rectangular plate about for an axis that is passing through its center of mass and perpendicular to its plane. This is 1 by 12. For this axis, it is 1 by 3m L square plus B square. About this axis, this will be this will be 1 by 3 mb square. About this axis, it will be 1 by 3. This will be ml square. This will be 1 by 3 mb square. This I3, that will be 1 by 3 m L square plus B square. And this will be 1 by 12 m L square plus B square. So these are the moment of inertia for this rectangular plate. ठीक है ना? This will be the different moment of inertia I have calculated about different axes here. So this
Sir?
is, yes, beta, please.
तो ये पैरेलल एक्सिस थ्योरम और परपेंडिकुलर एक्सिस थ्योरम का वो प्रूफ थोड़ा अगर इसका इंट्यूटिव आइडिया कैसे होता है ये तो बता
बेटा
दीजिएगा।
हाँ ओके, वो देखते हैं, ठीक है, अभी कंटिन्यू करते हैं इसे ही बेटा. So this will be the moment of inertia for this. Now next, so this is for the rectangular plate. बेटा आपने ये नोट डाउन कर लिया सभी ने? ठीक है.
Yes, sir.
Next, there is a non-uniform road. What will the moment of inertia in case of non-uniform road? ठीक है. So a road is given to you. A road is like this. This is a non-uniform road. This is non-uniform road. ठीक है. You want to find out moment of inertia about this axis. This is the center of this. C. You want to find out moment of inertia of this rod about this axis. But non-uniform means it's lambda. Okay? It's lambda. It is depending upon, ठीक है ना, it is depending upon different position. It is changing. Its lambda is changing with its length. With its length, it is changing. So what is lambda? Suppose lambda is a times, a is a constant, mode of x. ठीक है, mode of x. This is origin also. This is not only center of mass, this is also origin. And x is the distance from the origin. So on this side, it will be plus x. On this side, it will be minus x. So basically here, this lambda is not constant. Lambda is varying with x. That's why you are saying this. This is a non-uniform rod. Now, if you are rotating this non-uniform rod about this axis, what will be the moment of inertia? Okay, you have to find out moment of inertia about this axis passing through its center perpendicular to its length. So first I want to find out mass of this rod. So for this purpose, I consider a length element. Here, infinitesimal length element I am considering. Its length is, कितना है इसका length? dx. dx is its length. ठीक है? dx इसका length है. At how much distance I am considering this element? At x distance from here. This is. What will be the mass of this element? Mass of this element will be dm. dm, and this will be lambda into dx. Lambda into dx. Lambda into dx. Now, try to understand this. Look at this. So this lambda, okay, this lambda is a mode of x. So whatever mass distribution is here in this direction, same mass distribution is here in this direction. Try to understand, if you plot this mode of x, you are going to have the same type of plot. So if you plot this, here we are going to have x. This is origin. This is lambda. So what you are going to find out, you will have like this. This will be, what will the lambda on this side? This will be ax. ax. On this side, x will be negative, and similar, identical, symmetrical line you are going to, thoda angle, this will be same. Here lambda will be how much? This will be minus a of x, because x will be negative here, so minus it will be plus. So on both sides, symmetrical distribution of mass is there. Whatever mass is distributed here, the way in which mass is distributed here, in the same manner mass is distributed on this side. So if I consider that only this part is rotating about this axis, it will have some moment of inertia. Now, if I start rotating this part, this will have the same moment of inertia. So both these parts, they are going to have same moment of inertia if you are rotating these parts about this axis. Okay, it is due to symmetry. Why it is? It is due to symmetry. So whatever structure it is, this half is going to create same structure on rotation it is going to create. So symmetry is there. Symmetry in mass distribution is there. So that's why their moment of inertia will be equal. That will be equal. So I'm removing this. This was just to show you. Now, what will be the moment? What will the mass here first? So mass will be mass of the rod, you can say. That will be integration of dm. This will be integration of dm. Okay? So whatever mass, this half rod is going to have, same mass it is going to have. So I'm making it 2 times. Okay? I make it 2 times integration 0 to L by 2. I'm choosing. Okay? This is 0. This will be L by 2 here. This is minus L by 2. So 0 to L by 2, and make it double. Lambda is a mod of x, because you are in the positive side of x, 0 to L by 2. So this will be a times x, and this will be dx. This is lambda into dx. So lambda will be ax. If x is positive, it will be ax into dx. So this will be 2a. This will be x square by 2. So you can write L by 2 square divided by 2. So this will be AL square upon that will be 4. This will be the mass of this road. So first I have calculated the mass of the road. Mass of the road will be, this will be AL square upon 4. This will be AL square upon 4. Next, now I want to find out moment of inertia. So again, what will be the moment of inertia? Moment of inertia will be I. So I will write here 2 times. I'm going to calculate for this half. Same will be for this half. So I'm making it double integration. I'm making it 0 to L by 2. ठीक है? 0 to L by 2. For this element, what will be the moment of inertia? That is, x is the distance from the axis of rotation. So I write x square here multiplied by dm. So this will be the moment of inertia of this road about this axis. About this axis. So what it will be? This will be 2 times. Where is dm? dm is lambda into dx. ठीक है? और lambda is ax. So I'm writing a here. This is x square. It will be as it is. In dm, this is lambda ax dx. So it will be x into dx also. ठीक है? So this will be x cube into dx. It will be x cube into dx. But so you can write it. 2a is out. This is L by 2. Here, this is 0. So this will be x cube by 3. And this will be L by 2. And this will be cube beta. So 1, 2 will cancel out. So this will be AL square by 12. ठीक है ना? 4 3s are 12. So how much it will be? This will be AL square by 12. Is it okay?
Sorry, L raised to 4.
Sorry. This is x. No, ये 3 है. Sorry. This is, you are okay. So correct it. Actually मैंने इधर ये x, this is x square ना? So this is x square. So this is becoming x cube. Sorry. So write here 4 and make it 4. Now it will be correct. So here it will be, sorry. अरे भाई. This will be L by 2. ठीक है? So this 2 is going to cancel here. ठीक है? And it will be 2 into 2 to the power 4. 2 into 2 to the power 4. So this will be, ठीक है? तो कितना हो जाएगा? 1632. ठीक है ना? It will be how much? It will be 32 AL square upon 32. 32. If you want to write it in terms of mass, अगर आप इसे mass के term में दिया है, you can write from here. So this will be A. A will be how much? This will be 4m. 4m upon L square. ठीक है? From here, if you want, suppose they are providing the mass in place of this, then this will be 4m upon L square. ठीक है? This will be A. Substitute here. Substitute
यहाँ पे
here.
L की पावर 4 आ जाएगा ना?
क्या बेटा?
square
L to the
होगी L
power
की power 4.
4. Okay, बेटा. This is L to the power 4. ठीक है? Now substitute this. So this will be 4m upon L square. 4m upon L square in place of this. And this will be L to the power 4 upon 32. So this will be ml square. ml square. ठीक है ना? And this will be 1 by 8. 1 by 8. So this will be, in terms of mass, if total mass is given, it will be, I will be 1 by 8 ml square. It will be like this. Okay. So in this way, you can calculate. If they are saying that, what will be the moment of inertia about this axis? What will the moment of inertia about this axis? Then this is IC actually. This is IC. So what will be I? This I will be IC plus mass of this road, and this length is L by 2. This is L by 2 from here to here. So this will be L by 2, and square of this. So in this way you can find out. So you can find out mass in terms of mass as well as you can find out in terms of lambda also. This is your choice. So जो एग्जाम में पूछा था, I think this question was there in TIFR. So this type of answer was there. ठीक है ना? This type of answer. Yes, beta, please. Yes.
सर यहाँ पे अगर लैम्डा हम लोग मॉड एक्स को नहीं लेके कोई भी और फंक्शन ले लेते हैं, लैम्डा को और फंक्शन ले लेते हैं, तब तो
ठीक है,
इंटीग्रेशन तब क्या हो जाएगा?
पूरा करना पड़ेगा बेटा. Then integration will be from here to here. ठीक है ना? Integration will be from minus L by 2 to plus L by 2. You are doing 2 times only because you know mass distribution on this side and mass distribution on this side, they are symmetrical. But अगर suppose your जो plot है, plot of mass distribution is not symmetrical, ठीक है, about this axis, then automatically what can you do? You have to integrate this from the limit minus L by 2 to plus L by 2, corresponding to the given value of lambda. ठीक है, you can try. ठीक है, आप कर सकते हो इसे ax के लिए कर सकते हो. You can write like this. देखो निगेटिव तो नहीं होगा. निगेटिव मास डेंसिटी को बेटा आप ऐसे नहीं लिख सकते ना. You cannot write mass density like ax or ax cube. In that way, there will be a problem. But what can you do? ठीक है, you can choose. You can do one thing. I can show you. If you want this type of problem, then you can consider a road like this. Consider this point as the origin. ये point को origin लो. And this is the axis about which you want to find out. And lambda is suppose ax. It is like this, or ax cube if you want. So directly you can find out with
Okay,
respect
sir.
to this.
Got it.
ठीक है ना? You can directly find out. This is for the non-uniform road. Now, you have to find out moment of inertia for equilateral triangle. Equilateral triangular plate. Equilateral triangular plate. Here, if you are having a equilateral triangle plate, suppose its side is A. ठीक है, side कितना है इसका? A मान लो. Mass you can say that its mass is M. आप इसका mass है ना M consider कर सकते हो. Side is suppose A. So you are going to have this type of plate. You are going to have this type of plate. Equilateral triangular plate. Side is A. ठीक है, and mass is M. Mass is M. So what can you say about its moment of inertia without calculation? Mass is M, this is A. So what can you say about the moment of inertia of this from the plate or from the disk? You have the example of the disk, you have the example of the rectangular plate, or ठीक है, square may be there.
सर
So
इसको डिस्क बनाने के लिए एक और
yes, I just can say that its moment of inertia, I want to find out about its center. Centroid, you can say. This is the centroid here. ठीक है, this is C. I want to find out about this. So I can say that moment of inertia about this, about C. One thing I can say, I don't know its value. I don't know this eta. This eta is some constant, but it will be ma square. You can solve many problems where symmetrical type of structures are there. You will find out moment of inertia will be proportional to its mass as well as whatever symmetrical number is here, symmetrical parameter is there, is square of that parameter. So you can say, just you can only predict this, that I can be ma square multiplied by some number. I don't know that number. I want to find out this eta. तो मुझे ये eta चाहिए. ठीक है? This is my objective. I want to find out this formula. What is this formula for this equilateral triangular plate? So what do? You do very simple thing. Place. So I'm using another color here. You are having a rectangular plate here. Not rectangular, sorry. Equilateral triangular plate. Similar, identical type of plate I'm choosing here. It is like this. I'm choosing another rectangular, this equilateral triangular plate. That will be here. So you can consider like this. This. And third is this. This is also, they are all identical. They are not looking like identical, but they are all identical. ठीक है, मुझे ठीक से बना नहीं, but try to understand what I do. I will create this type of picture by placing identical equilateral triangle angular plate. This, and this. Now, can you tell me what will be this side? That will be A. This will be A. So this side is 2A. If you look at this larger picture, this is also a equilateral triangle. So what will be its side? That will be 2A. If you look at their sides, that will be 2A. 2A. And this point, it will be the center of mass of this. Okay, this will be the center of mass. This is two part, this is one part. Try to understand. If you draw this line, so 3 part will be here, 1 part will be here, 2 part will be here. So this is 4:2. So this will be 2:1. So automatically this will be the C point, center point. Okay, centroid point for this larger equilateral triangular plate. So it will be like this. Now, can you tell me, if I rotate this equilateral triangular plate, larger equilateral triangular plate about this, what will be the moment of inertia? What will be the moment of inertia? So I write here, this will be I. I write it as big equilateral triangle. This eta will be same. Formula is not going to change. If this is the formula for the equilateral triangular plate, so automatically same formula will be applicable for this. So this will be eta. Mass kitna ho jayega? What will be mass? 1, 2, 3, 4. 4 times. So mass will become 4 times. 4m. What will be this A? That will be 2A. This will be kitna ho gaya beta? 16. This will be, you can say 16I. This will be 16I. ठीक है, सो इट विल बी 16I. तो लार्जर जो आपका प्लेट है उसका कितना हो गया बेटा? 16I हो गया उसका. इज इट क्लियर टू एवरीवन व्हाट आई एम सेइंग?
Yes.
ठीक है. नाउ दिस इज वन वे. नाउ कैन यू टेल मी, can you find out, if you consider them individually, you are individually considering this and this. Can you find out the I big? This I big? So this complete structure is made up of 4 parts. One part is this. Second part is this, suppose. Third part is this. Fourth part is this. I'm writing fourth part is this. So it is made up of fourth part. What will be the moment of inertia of this original white color equilateral triangle if you rotate about this point C, about this axis? That is I. You know this. I'm not going to change the axes. Now, for this equilateral triangle about this C, try to understand this point. ठीक है ना? This point. This is the C points. You can say this is C3. C3. This is C3. ठीक है, what will be the, if you rotate about this will be simple eta ma square. It will be, कितना होगा ये? I के equal होगा. Now what will the moment of inertia of this number 3 equilateral triangle if you are rotating it about this? So use parallel axis theorem, find out this distance. तो ये जो डिस्टेंस है ना, ये वाला डिस्टेंस यहाँ से लेके यहाँ तक, मुझे ये डिस्टेंस चाहिए. I need this distance. I need this distance. ये डिस्टेंस कितना होगा बेटा? You are going to tell me. So you have to find out this. ये distance चाहिए आपको. बोलो बेटा कितना होगा. This is two part here. This is one part. This is one part. Two part is here. ठीक है. This C point, it is going to divide this perpendicular into two part. Two part is here. One part is here. So this one part I need. I need this one part, and this is double of that one part. ये पूरा length कितना होगा in this equilateral triangle I am using here. Here this is A. So what will be this total length? This is 30 degree. So this will be A cos 30. ठीक है. ये कितना हो जाएगा? This will be A cos 30. And this point is C. If I call it as A, this point as A, I'm calling. So what will be CA? CA will be कितना होगा? 1/3 of this A cos 30. So this will be कितना हो गया? 1/3. ठीक है. A is here √3/2. 2. ठीक है. Now you have placed two equilateral triangles side by side. Like this you are writing. This is C also. So what will be the separation between C1 and C2? That will be 2 times of this. So C1, C2 कितना होगा बेटा? 2 times of this. This will be A by √3. So what it will be? This will be A by √3. So what will be C1, C2? C1, C2 will be A by √3. Is it okay? So what will be the moment of inertia of this? So I'm drawing here for you for this triangle. I want to find out the moment of inertia of this triangle about this axis. About this axis. I see you are aware. So apply parallel axis theorem. This axis and this axis. So apply parallel axis theorem. So कितना होगा इसका बेटा? I'm writing here. So this will be plus. That will be I plus mass of this. And this distance is square of this distance. This will be A square by 3. Yeah, you can write A by √3 and make the square of this. So this will be due to this. Similarly, similar situation is here for this. This is another. What will be the moment of inertia of this triangle about this? Same you are going to get for this. Then go for this third one. What will be the moment of inertia of this triangle? About the same point C, about the same axis. This axis passing through this C, perpendicular to the plane of this plate. Same. So it will be 3 times here. So it is going to be 3 times. So you have find out the moment of inertia of this larger equilateral triangle in 2 ways. First, I apply the formula that I have assumed. I have assumed that for equilateral triangle, formula will be eta ma square. I'm clear about ma square, but I'm not clear about this eta. I don't know this eta. I want to find out this. Now, if you are creating this big picture, so same formula I apply, and this is 16i. 16i. In another way, I can also calculate it. Actually, this larger picture is made up of 4 parts. 1, 2, 3, 4. The first one is okay. For first one, ये जो center वाला है, for this moment of inertia about this axis, this will be I. I'm clear, I have written this. For this, for these 3 parts, it will be equal. कितना होगा? I will be there. ठीक है ना? This. And then I shifted this by using parallel axis theorem. So I find out this distance first. That distance is A by √3. So this will be, it is going to be like this. Now, I'm removing this part, but please note it down. Please note it down quickly. In the next class, I am going to start moment of inertia tensor. So up to the point, I was handling only those problems where you are rotating the structure. You are rotating the rigid body or system of particles about an axis where during rotation you are getting symmetrical type of structures. So you are rotating about principal axes. But now we are going to move for more general cases. So for that purpose, we need moment of inertia tensor. So in the next class, I'm going to start discussing moment of inertia tensor. So what is I big? I big is 16 I beta. 1 I is here plus 3 I is here. Okay? And this will be MA square. MA square. And this will be here root 3 square. This will be 3 and 3 will be here. 3 will be here. So make it, this is 4, this is 16. So this will be 12I. And on this side, you are going to have MA square. So I will be equal to 1 by 12 MA square. This is the answer of this square. This is MA square. 1 by 12 MA square. Okay, now this will be the moment of inertia of a equilateral triangular plate. Okay, in the next class, I can even discuss some right angle triangles you can find out. If you are having a right angular triangular plate, you can find out. For other plates also, you can find out. So at least one case I will surely discuss in the next class. So here you are able to find out this one. This is the moment of inertia of a equilateral triangular plate. Is it clear to everyone, beta?
Yes,
Is
sir.
this ठीक है?
sir.
Good, beta. So I'm trying to discuss each type of case. I cannot discuss all the cases, but I'm going to discuss those cases on the basis of which questions can be designed, particularly in TIFR exam and IIT JAM exam. ठीक है, particularly these two exams. ठीक है, this type of methodology is very important. In TIFR, you will find out many questions which are based on this. Next, suppose you are having a cone. ठीक है, I'm talking about a solid cone. Solid cone. So you are having a solid cone like this. Its base, this is the base, or it's its symmetrical axis. Suppose height of this cone is h. What I'm saying, height of this cone is h. तो इसका height कितना है बेटा, h है. Second, जो base है, radius of the base is a, and mass is m. और इसका mass कितना है, that is m. तो इसका mass m है बेटा, base का radius a है, and height is h. Now I want to find out the moment of inertia. If you rotate this about this axis, if you rotate it about this axis, what will be the moment of inertia? I want to find out this. Okay, this is my objective. So for this, can I cut it in slices? If you cut this cone into slices, then you are going to get plates. If thickness of the plate is very, very small, okay, if thickness of, then you can say that this is made up of infinite number of plates whose radiuses, they are different. Radiuses of these discs, which will be formed by cutting, by slicing this cone, ठीक है ना, their radius will be different, but you are going to get large number of it will be infinite number or very large number of discs you are going to get. So what you are going to get, you will get this type of disc. I'm showing you here. I'm assuming one such disk. So this one such disk is this one. So this type of disk you are going to have. So this is a disk. This type of disk structures you are going to get here. Okay? You are going to get here. So what I assume here, I'm assuming that suppose radius of this is r, or I can say this is x. I assume this radius is x. ठीक है, from here this distance is z, यहाँ से यहाँ तक. At a distance z I am considering a disk whose radius is x and width of this disk is infinitesimal and I call it a dz. कितना होगा ये बेटा dz? So you have sliced this into infinite number of plates, disks. Width of each disk is infinitesimal. I am assuming its width is dz. At what distance along the axis? At what distance I am choosing the disk? At a distance z. So automatically this distance, this will be h minus z. ये कितना होगा? That will be h minus z. So it will be like this. Now, if I assume this angle is alpha, if I assume this angle is alpha, then what will be tan alpha? Tan alpha कितना होगा? देखो, try to understand tan alpha. You are having this greater right angle triangle. This is perpendicular is A and height is h, so I can write it as A by h. A smaller triangle is here. This is x and this is h minus z. So I can write it as x upon h minus z. So I can write x equal to A by h into h minus z. So I have correlated this x and z because two variables are here. Try to understand, one is x and another is z. So two variables are there, x and z. So I have connected them. I have connected x with z. Now, second thing is, what will be the moment of inertia of this disk? इस डिस्क का मोमेंट ऑफ इनर्शिया कितना होगा? देखो, मोमेंट ऑफ इनर्शिया ऑफ दिस डिस्क I can write as di. For the disk, formula is 1/2 mr square. Mass of this is suppose dm. What is the radius of this? That is x square. This will be the moment of inertia of this disk. Now what will be dm? dm कितना होगा? If you look at dm will be equal to mass density. ठीक है ना? Mass density multiplied by volume of the disk. ठीक है ना? Volume occupied by the disk. What will be the density here? If you write this density, total mass is m. What will be the volume of this? कौन कितना होगा बेटा? 1/3
1/3 pi
pi a
square
square h. This will be rho. What will be the volume of this? ये कितना होगा? Pi x square. इसका एरिया कितना होगा? Pi x square. Pi x square multiplied by dz. This will be the volume. So this pi is going to cancel out. And this will be 3m upon a square h. And this will be x square dz. Is it okay बेटा? ठीक है, check it. ठीक है, this will be. तो इसका कितना वॉल्यूम होगा? ये डिस्क है बेटा. डिस्क का क्या है? एरिया ऑफ द सरफेस, दैट इज पाई एक्स स्क्वायर multiplied by its width. Width is dz. So this will be x square. This will be dm. Substitute here. So this will be here. This will be 3. 3/2 is here. 3/2 is here. This will be m upon a square h. And this will be x square is here. X square is here. So this will be x to the power 4. And this will be dz. dz. Now in place of x, write this one. So what it will be? This will be 3/2 m a square h x to the power 4. So this will be a to the power 4 upon h to the power 4, and this will be h minus z to the power 4, and this will be dz. This will be di. This will be di. ठीक है? So Here, this is a square, this is a to the power 4, so a to the power 2 will be left. Now, what will be the moment of inertia of this complete system? That will be I. You are going to integrate this di. So it will be 3 ma square here. This will be 2 times h to the power 5. H to the power 5 will be here. Integration h minus z. And this will be 4 and this will be dz. And ये कहाँ से कहाँ तक होगा बेटा? 0 से लेके h तक. Yes, beta? Yes, please. So this will be the moment of inertia of this complete structure if you are rotating it about this axis of symmetry. This axis of symmetry, you are going to get this. So what it will be? ये कितना हो जाएगा बेटा जब इससे? This will remain 3ma square upon 2h to the power 5. When you will integrate this will be x to the power 5 by 5. So I'm going to write 1 by 5 here. And you will divide this because this is h minus z. So you are going to divide it by minus 1. So minus will be here. And it will be h minus 0, h minus h to the power 5 will be here. Upper limit minus this will be h minus 0. So this will be h to the power 5 here. It will be like this. It is going to be like this. Okay? Okay? So here this will be 0 and this minus is gone. H to the power 5 is gone. What you are going to get? 3 by 10 ma square. This will be the moment of inertia of this cone about this axis. Okay? So h to the power 5 is this is 0 beta. This minus is cancelled out by this. H to the power 5 is gone. So we are left with 3 by 10. Okay? 3 by 10 ma square. ma square. 3 by 10 ma square. This will be the moment of inertia of this solid cone about this axis, z axis. Suppose this is z axis. So this formula you have to remember. So today I am going to stop here. In the next class, I will discuss 1 or 2 cases of triangular plates. Okay? And then I will give you some other formulas. All the formulas I am not going to discuss. I am not going to drive. Then I will explain you how to find out tensor, why tensor is coming into the picture, and how we are going to get the tensor, moment of inertia tensor. And later on, we will learn how from the moment of inertia tensor, you can find out the moment of inertia of this rigid body about any arbitrary direction. You can choose any arbitrary axis and you can find out the moment of inertia of the rigid body about that axis. ठीक है बेटा? चलिए बेटा. Yes, बेटा. Yes, please. Please switch off your mic. Please switch off your mic. चलिए बेटा आज यहीं रुकते हैं. Thank you very much. आपको ये सब समझ
Thank
आ
you.
रहा है ना बेटा सभी बच्चों को? हेलो.
Yes, sir.
ठीक. If someone is having any problem anywhere, you can ask at the same time. ठीक है? Even if you are having problem, you can message me. I can even discuss in the next class whatever your doubt is there. चलिए बेटा. Thank you very much.
Thank you, sir.
Welcome.
Thank you,
बेटा.
sir.